The primary focus of this video is going to be showing you how easy it is to set up a mini PC like this as your little home lab server to do a variety of things, whether if you want to host services such as media servers, you need a file transfer server, a bunch of different things. We're going to be setting up Portainer with Docker. It's going to be awesome. Now, this video is sponsored by GEEKOM, mostly to feature their mini IT11 mini PC, which is a great option for doing this. And of course, there are going to be timestamps and you can mimic basically all of the steps later on with any other mini PC, even any server or computer that you want to try this out on. Again, GEEKOM did go ahead and send this over mostly to promote their store and variety of mini PCs that they offer, whether if you want to use their Intel NUC distributor store or their own branded products, and they are running a sale on this guy right now, in which depending on the model and specifications you pick, you could get this guy anywhere from $400 to $600. A cool thing about what we're doing is a lot of the server services that we're using aren't too demanding, so using older gen things like this as an 11th gen i7? Yeah, i7 is going to do absolutely more than what we need for what we're going to be doing. And it's an Intel machine, so it is really easy to set up hardware acceleration for things like media servers. Now, first opening it up, we get just about everything you'd expect with our mini PC presented up front. Moving this out of the way, we have a little card here basically saying thank you. Under all that, we have our power and HDMI cord. We got some screws and the VESA mount that comes with it, just in case if you do need to mount this behind your computer. And of course, we have our manual. Now, let's grab our little mini computer real quick, unwrap it from the plastic and check out some of the I/O. On the front here, we have a USB Type-C 4 port. We have a USB 3.2 Gen 2 port, 2.5mm headphone jack, as well as our power button. The ventilation is along both sides, but each side does have something a little special, including the right side having a Kingston security lock, and then the other side actually have an SD card reader, which is very convenient. Now, taking a look at the back, we have our power input, and we have a mini display port. We have our internet port, which unfortunately is only a gigabit. As it is a couple years older, some of their newer models have a 2.5 gigabit, but with that, for what we're going to do, it's going to deliver more than enough when it comes to the speeds. And then we have a pair of USB 3.2 Gen 2s, another USB Type-C port on the back, as well as a standard HDMI. Opening up the computer is pretty standard on the bottom. There's going to be 4 screws where the foot pads are. You loosen the screws and the bottom should be able to pop off, exposing the components that you're able to replace, which include the 32 gigabytes of DDR4 RAM that my model shipped within the 1TB NVMe SSD. This computer comes in both i5 and i7 configurations. The specific model I have has a Intel i7-11390H, which features 4 cores and 8 threads. Now, before actually setting this up as a server, I did use Windows on it for a little bit just to kind of play with it, and overall it performed really good. I fired up Geekbench, in which it scored about 2000 on the single core performance and 5500 on the multi-core performance. Not as fast as the 13th gen i5 we checked out about a week ago, but still pretty good speeds nonetheless. Now, once I kind of was done playing with Windows a little bit, I threw Ubuntu on it. Again, it ran perfectly fine. It was overall a really good experience. And one thing that's kind of cool is the last time we checked out one of these, I believe the NUC 13 Pro, Windows benchmarked a little bit better. This Intel generation is a little bit older, so I could be wrong, but I think that the drivers and all that have been optimized and improved over time in the Linux kernel, because in the case of the NUC 13 Pro, Windows actually benchmarked a little bit better. In the case of this mini IT11, Linux actually benchmarked a little bit better, with about a 100-point increase on the single core score and nearly a 500-point increase on the multi-core score, which is awesome because I'm going to be throwing Ubuntu server on it in a little bit. Also, while I was in Windows, I did some additional benchmarking, one with NovaBench, where it got a total score of just about 1500, clock speeds at 3.6 gigahertz. DirectX was pretty low at 13 frames per second. The memory peak speed was just under 10,000 megabytes a second, and the read-write speeds for the SSD it came with was just under 3,000 megabytes a second. And I did try to run NovaBench on Ubuntu, but NovaBench on Linux at the moment is basically broken, even with all the little hackery things I did to try to make it work. In Basemark Web 3.0 on Windows, we got a score of 993, and in Ubuntu, also on Edge, we got a score of 973. Now, before we get into the server stuff, I was kind of interested in the gaming performance of this 11th gen Intel machine. So first, I wanted to try kind of a newer AAA title. I tried Ghost Recon, the Wildlands Special Edition, and it was playable. It was getting about 20 frames per second, which for the game and for the hardware is actually kind of decent. But I wouldn't use this as like a AAA gaming machine. When it comes to other games, the performance was actually surprising. As with a game like Splitgate, 1080p, medium settings, I was getting high 60s to 70s when it comes to frame rate. So playing games like that was really good. There's no stutter, no lag. We can see that it's using very little of the CPU and just about half the RAM. So gaming performance on this really just depends on the games you're trying to play. It could either be really, really good or playable. So with that, now let's do what I love to do most, and that's turning things into servers. So go to the Ubuntu website, download the latest LTS server edition. I always recommend LTS when it comes to these servers. And once you download the ISO, you're going to want to get a USB and use a tool such as Etcher to go ahead and flash that. If you're already on Linux, GNOME disks is my preferred way to flash drives. You click on it, restore image, select the ISO. It's real easy. And with it flashed, you're going to want to go into your BIOS and select it as the boot device. I'm not sure what the BIOS key is. I just kind of spammed delete F12, F11, escape, F1 and F2, like that, popped myself in the BIOS and then booted up the Ubuntu installation. Installing Ubuntu server is really easy. First, you just select your language. There's an option to update to the new installer. I generally do that. And then you give it a minute, let it process that. Of course, at this point, we're using a screen to do this, as well as a solid Ethernet connection. Later on, you're not going to need a screen anymore because it is a server. Once the installer updates, then you're going to want to select your keyboard layout. And from there, pick your installation. You have Ubuntu server, you have the minimal version, and the option to search for third-party drivers. I always select Ubuntu server. You might as well search for third-party drivers, but being that this is a pretty basic Intel machine, all the drivers are going to be baked into the kernel. From there, we have our network configuration. If you already have it plugged into Ethernet, it should be giving you an IP address, and it is important to note this is the IP address that we're going to be using later to actually SSH and do some things in it. So do kind of write that down or remember it, or we could always use a command to get it later. There is an option for Wi-Fi. If you really don't have access to an Ethernet port, you can set this up with Wi-Fi, but it's generally not as quick and not as stable as just using Ethernet. From there, we have a proxy address. I'll leave a link down below if you're interested in learning that and setting that up, but I always usually just skip that and use the IP address. It's going to test for an appropriate mirror. Just go ahead, once it does that, continue on. And then the next step is actually picking our hard drive. Now, of course, I will note that if you have Windows, which comes pre-installed on this, it is going to completely wipe that, which in this case I am perfectly fine with. The default is to use the entire disk, set it up as a LVM group. You do have the option to encrypt it, but this is just a little home server. I don't really need it encrypted, but if you do want the extra security, you can do that. So from there, just tab down to done and then continue. The storage configuration will kind of give you a layout of everything that it's going to be doing, including the root, boot, and EFI partition tables. When you click done from there, you're going to get a prompt telling you what I just told you. It's going to wipe everything, continue there, and then you have the normal name, server name, username, things like that. For the server name, I usually like to identify it based on the machine name, so I picked the GEEKOM Mini IT11 or GEEKOM IT11. Here you have the option for Ubuntu Pro. Let's go ahead and skip that for now and probably forever. And now here, this is really important. You are going to want an open SSH server, so you don't actually have to physically be on the computer. You can remote into it and run all the commands. So you tab and you hit the space bar to go ahead and select and put that X there to make sure that it gets installed. If you're familiar with SSH, you can import an SSH identity, but for me, I'm just going to select to install that server and then go to done. And like I mentioned earlier, it did do that third-party driver search. There are none, which is cool, so we will continue. Now here, you get some pretty convenient options to install some popular services such as Nextcloud, Docker, PowerShell, a couple different things. I am going to skip this for now because I kind of want to show you the commands to do this a little bit later, but if you wanted to, you could install Docker through here, which is the snap package. Now, ever since we selected our disks, it has been installing in the background, so at this point, you're just going to want to let it finish up what it's doing. You can see it's currently installing the kernel, and it's going to do everything else for us. It's also going to run some updates in the background. You can cancel this and reboot, but just let it finish what it's doing. And when it is done, you'll see the option just to reboot now. You're going to want to go ahead and do that. And now at this point, we could go ahead and log on to our machine. If you enter a couple times, you will be prompted to log in. Type in your username and password and we're good to go. And just for good measure, I always do a sudo apt update, run that, and then a sudo apt upgrade, just to make sure we're up to date before I go ahead and like remote SSH into it. Now, just a little tip before we SSH, if you did forget your IP address, you could do IPA It will list your network cards and their IP addresses. You can see mine is ending in 118, and that is what I'm going to use to connect to it. Now, since I did update the machine, just for good measure, I'm going to go ahead and reboot it. And then when it fully reboots, we could technically unplug the monitor and remote into it, which is what we're going to do now. So right here, I have a terminal up and ready to go. You could kind of see I just tested out to see if I could connect. To SSH, you're going to want to do SSH, your username, and then the IP address from the IPA command. Hit enter. At this point, it may ask you if you want to import a key because that's your first time connecting to it. Just say yes, and then from there, type in your password, and then we can see we are connected. And the cool thing about using Ubuntu server is there's documentation to do a lot of different things. Right here, this is the official Docker docs. Right here, we have the convenience script, which will go ahead and pull all the things we need to install Docker. So all we need to do is first copy this curl command here, paste it on in, hit enter. So basically what that did is grab the script. If we ls, which is the command to actually list everything in our current directory, we could see we have the git docker script there. And then we have the option to do it as a dry run, which is going to show us everything that it's doing. So I'm going to copy that, drop it on in, hit enter. It's a sudo command, so we're going to type in our password, and we can get a list of everything that it's going to be doing. So we can see it's going to grab some key rings. It's going to grab the Debian packages for that. It's going to install Docker CE, CLI Containered IO, Docker Compose. So now let's run that without the dry run. So we're just going to run all those commands that were listed. So if we hit enter here, it's going to begin doing everything that it said it's going to do. And boom, there we go. To run Docker as a non-privileged user, consider setting up this. We're just going to do it as a privileged user for now. And now just to really make sure, I should be able to run something like docker-v, which is going to list out the version of Docker we are currently running. And we can verify with this docker hello world command. So if I go sudo docker run that, enter, you can see it's pulling, and then we have the hello from Docker. So we are good to go. Now, what we're going to do real quick is set up an application called Portainer. Now, what this is going to do is give us a really nice user interface to actually manage and add stacks or Docker Compose files, things like that. Portainer is what I'm currently using on my dedicated Intel NUC machine that I have running Plex. So on this install page here, we're going to go to the Portainer CE, which is the community edition, and setting it up is real easy. If we go set up a new one, we want to do this on Docker standalone. It's going to be on Linux, and then all we need to do is run these two commands here. So first we are going to create a volume for it. So hit enter. And of course, like I said, we're going to be doing this as a sudo user. So enter, we have now Portainer data. And then we have this command here. Now this is going to run it on the ports 8000 and 9443. The name is going to be Portainer restart always. And then this right here, the volume to the Docker sock, it's going to be able to, so it can do admin Docker tasks, which is kind of the point. And then it's going to point at that volume we just created, and we're going to pull the latest branch. So from here, let's just paste that on in, hit enter, again, sudo, hit enter, and then it's going to pull all the images and everything. There we go. So now what we should be able to do is go to our server IP address, and we're going to want to do this as HTTPS, and type in that IP address, the same one we connected to via the remote or via SSH, which I did forget. So again, IPA is how you're going to figure that out. It is on 18, so we're going to want to go 18, and it is on the port 9443. Hit enter, connection not private, that is fine, it's my server. So basically at this point, you've successfully set up a server, you've set up Docker, and this is your first kind of web dashboard to go ahead and manage things. So username, I'm going to go Brandon. Make sure you do a pretty strong password because this one will not allow you to proceed if the password is not strong enough. And we're going to keep that checked, create user, and here we are. From there, we're going to want to click on get started. This is our new local environment. If we jump into it real quick, you can see we have 2 containers, 2 images, 1 volume created. If I go into containers, we are going to see one of the hello world container that we created when we were testing it out, and we have Portainer. Now, I'm never going to use this hello world thing again, so I'm going to just click the check, click remove, remove the volume, and remove it. So now we are really only running Portainer. And it's really at this point, you now have the infrastructure set up where basically the world is at your fingertips. Now, an example of a service that I use is this right here called Homepage. What this is an application that allows you to kind of make a bookmark page of your various home lab services, links, really whatever you want. So for example, if I wanted to deploy this with Docker, it gives us a Docker Compose image right here. Now, this isn't a full-fledged tutorial on how to use Docker and all that. I do recommend you kind of learn some of the variables and things, but I'm just kind of showing you how easy it is to get some of these things up and running. Stacks right here, like I mentioned earlier, is how we're going to mess with and use Docker Compose templates and images. We can add a stack, and stacks are really good if you want to use a Docker Compose image that has like a bunch of different services and things connected to each other that you want to deploy as one stack and manage all those various containers together. A good example would be like the R applications, Sonar, Radar. Deploying all those as a single stack is very beneficial, but in this case, we're just going to spin up one really simple file or one really simple container here. We have the version, the image it's going to pull, the container name. We have our ports here. So this is going to be on the port 3000. Do make sure that you don't duplicate ports because you're going to run into issues. Here you'll see this a lot, path to config. Do make sure you don't just keep that as is, because then it's actually going to make a path to config directory scheme on your installation. What I'm going to do just for this example is we're in our home directory right now. I'm just going to mkdir to make a directory. I'm going to call it Docker, and then I'm going to cd into that new Docker folder. I'm going to mkdir make directory to make another one, and I'm going to call this homepage. Hit enter. Now if I cd into that and then do the command pwd or print working directory, this right here is where I'm going to want those config files for homepage to live. So we're just going to copy that, go over here, and where it says path to config, we are just going to want to paste in that new location, which is home Brandon Docker homepage. And how you set all this up and all your configurations and things like that are basically up to you. When you're setting up media servers and that kind of R application of things that I mentioned earlier, you're going to want one place for a lot of different things, including your media downloads, things like that. And it is recommended to really read the documentation for various containers that you're setting up in depth so you know kind of how they want to function. But basically at this point, we are done with that. I'm going to name the stack homepage. That's really the only thing on it. If you were doing a bunch of media server things, you could call it media. You do have other options such as uploading a Docker Compose file directory using a repository and a custom template. We have some additional options here. You can add environmental variables, a environmental env file, which you may run into depending on the container you're using. Usually more complex containers with a lot of variables use these files. And actually one thing that I want to do, that's kind of a good tip, is I want to give my user privileges to go ahead and mess with all the configurations files of this. If I type in, I believe it's ID, I will get the ID of my current user, which is Brandon. My GID or group ID is also 1000. And you can see here under homepage, that was the most basic template. Here we have options to add these environmental variables. So I'm gonna just copy this. If you don't want to use Portainer, you could always just keep using Docker run commands here too. But I'm gonna jump back over here and then add those environmental variables. So just paste it in. And then here I'm gonna go with 1000 and 1000. Now, again, do be careful because then you're running this kind of as your user, and you may not want to do that depending on the security measures that you want for a specific container. So let's just deploy the stack. Usually takes no time at all. Obviously, depending on the actual size of the images and whatnot, we can see the stack has successfully deployed. If we go into this stack, we could see the containers that are associated with it here, or we could just jump over to containers and then we can see that home page right here is starting up. And a really cool thing about this is it's really easy to jump into the logs in the console. So I think right here is our logs. So if I open that up, we could see right now it's listing on port 3000. That's the only thing. No errors are spitting up, which is really good. If we go back to containers, we can see it's running. So now in theory, if I just go over here, I'm going to change this to HTTP, and this is running on the port 3000. So if I just go 3000, enter, we can see this is homepage. So another service that we spun up pretty easily. And then if I go over here in homepage, if I ls in the directory we just created, we can see there's a lot of different things. We have bookmarks, Docker, Kubernetes, services, YML, and really a lot more. And if you want to edit these, since I gave myself user permission, I should be able to just edit it, hopefully. So my user does have read-write access to these. We can see my first group, second group, third group, and it's working along with how homepage is, first group, second group, third group. I'm not going to go in a full complex tutorial on this specific Docker image, but if I added something such as media, output that, save it, go back to homepage, it's automatically going to reload, and then we have media there. Now again, homepage is super cool. If we go over to services for configuration, gives you a lot of detail on all the different variables and everything that you could use. And there are widgets, which is really nice, because then if you're using a lot of these different things, such as a radar here, you can set it up with an API key and you can see some information about that container within homepage at just kind of like a eyes glance. So with all that, that is how you easily turn a little machine like this into your very own server. If you're interested in doing this on like a laptop or something like that, I do have other videos kind of going through the same process. This is the first time I've used Portainer in one of these videos, which I've been learning rather recently, and it is a phenomenal tool. But overall, these are really powerful. They cool a lot better than a laptop does, and they're relatively affordable. You could get something even cheaper than this and have a really good server. So with all that, if you're interested in purchasing this, getting the deal on the mini IT11, there'll be a link down below, as well as to all the other GEEKOM products and whatnot. The video I just went over on the more powerful Intel NUC, and the very next video, or the last video in the series of GEEKOM products, is going to be this guy right here, the GEEKOM AS6, which is a super powerful AMD machine with the, I think it's the 6900 series CPU. I'm going to be doing a direct comparison of that against the Intel NUC 13 Pro, so do watch out for that video. It will be coming out in probably about another week or so. And with all that, I do hope you have an absolutely beautiful day, and goodbye.